Hello everyone. This video is about Chapter 4, Part 1, Discrete Random Variables. Firstly, I will show you the definition by a tossing coin experiment. When you toss a coin, it can be a head or a tail on the top. Now, we toss two coins. There can be four outcomes. Head, 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 tail, 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 and tail head. Now we define a variable called x as the total number of heads. Then for the first case, we have two heads, so x is 2 here. For the second case, we only have one head, so x here equals 1. For the third case, two tails, no heads, so x equals 0. And last case, x equals 1. This variable x is called a random variable. Generally, a random variable is a variable having numerical values associated with event of an experiment. Recall that in Chapter 1, we have learned the two types of quantitative data: discrete, which is integers only, and continuous, which has decimals. In this chapter, we will focus on the discrete random variables, integers only. In next chapter, Chapter 5, we will learn the other type, continuous random variables. Usually, we can use a table to list the probability distribution for discrete random variables. We denote the probability by px. The first row is variable x. We should list all the possible values of x. The second row is px. List the corresponding probability for each x. Let me show you with the example of tossing coin experiment again. X can be 0, 1, and 2. List them on the row of x. For x equals 0, there is only one case out of the 4 cases. The corresponding probability is 1 over 4. For x equals 1, there are 2 cases together: head, tail, and tail, head. So the corresponding probability is 2 over 4. Similarly, the corresponding probability of x equals 2 is 1 over 4. Here are two properties for the probability distribution of a discrete random variable. First, px is bigger or equal to 0 for all values of x. Second, all the corresponding probability sum to 1. That is, if one of the probability is missing, you can use the summation 1 to find it. Let's do a small game. Use $1 to buy a ticket, and you may have the chance to win $100. The chance to win the $100 is 1 over 101. Let x be the winning. We only have two outcomes of this game. Either you win the $100 or you do not win the $100. If you win the $100, you get the $100, but you use $1 to buy the tickets. So the winning is $99. The corresponding probability is 1 over 101. If you do not win the $100, you lose $1 to buy the ticket. So the winning is -1. The corresponding probability is 1 minus 1 over 101 because the summation is 1 totally. Now, you may be interested that whether the customers will expect to win or lose for this game, how much they will win or lose for this game. So we'll move on to the definitions. Firstly, mean of a discrete random variable is also called an expected value. The notation is mu or ex. It equals the summation of all the x values times the corresponding probabilities. For this game, the mean, which is the average, also called expected value, equals to the x value of 99 times the corresponding probability 1 over 101 plus -1 times the corresponding probability 100 over 101. The result is -1 over 101. That means, on average, the customer will expect to lose money. Next definition are variance and standard deviation. You can use either of these two formulas to calculate variance. For the first formula, use x minus the mean, then squared, and then times the corresponding probability. Lastly, sum all of them. For the second formula, use x squared times the corresponding probability, and then sum them. Lastly, minus mu squared. You can use either of them to find variance. The standard deviation is just the square root of the variance. Now, let me show you some details using an example. Here, x can only be countable numbers 10, 11, 12, 13, and 14. You may notice that the corresponding probability for 12 is missing. Use the property that the summation of all x is equal to 1. You can calculate the corresponding probability, and it will be 0.2. Now, let's use the definition to calculate mean first. Each x times the corresponding probability, and then sum them. The result is 11.8. For variance, you can use the original definition like this. Each x minus mean 11.8 and then squared and time the corresponding probability and then sum them. Or you can use the shortcut formula. Each x squared first and then times the corresponding probability and then sum them. Lastly, minus the mean squared, 11.8 squared. You can choose either formula to calculate variance. Lastly, the standard deviation is just square root of variance, square root of 1.96. The result is 1.4. Now, let's use the same example to do more questions. We will do one by one. A. Find the probability that x smaller or equal to 12. In this table, x can only be 10, 11, 12, 13, and 14. Smaller or equal to 12, it can only be 10, 11, and 12. So, add all the corresponding probabilities. 0.2 plus 0.3 plus 0.2 equals 0.7. B. X bigger than 12. X can only be 13, 14. So the probability is 0.1 plus 0.2 equals 0.3. 3. The corresponding probability for x equals 14 is 0.2. D is a conditional probability problem. In Chapter 3, we have learned that for the formula for the conditional probability, A is x smaller or equal to 13. It can be 10, 11, 12, 13. B is x bigger than 11. It can be 12, 13, 14. So A and B, the overlap of A and B is 12 and 13. Then add the probability of 12 and 13, 0.2 plus 0.1. Then divide it by probability of B. B is bigger than 11. It can be 12, 13, 14. So probability is 0.2 plus 0.1 plus 0.2. The result is 0.6. Let's see the last part, E. What is the probability within one standard deviation? Does it satisfy the empirical rule? Previously, we calculate the mean and standard deviation. Mean is 11.8 and standard deviation is 1.4. So, mean minus 1 times standard deviation, mean plus 1 times standard deviation is 10.4 and 13.2. In this range, x can only be 11, 12, 13. So the probability falling within one standard deviation is 0.3 plus 0.2 plus 0.1 equals 0.6, smaller than 68%, so it does not satisfy the empirical rule. Note that the probability fall within 1 or 2 or 3 standard deviation is a bit different from what we have learned from Chapter 2. For Chapter 2, the data, we count how many data fall within the range and divide it by the total number. But here, for the discrete random variables, we count which x falls within the range, then add the corresponding probability together. That's all for this video.